Asteroid Impact. Imagine a colossal rock, miles wide, hurtling through space at unimaginable speeds. This rock, an asteroid, has the potential to collide with Earth. Such an impact has occurred before, notably wiping out the dinosaurs 65 million years ago. The power of an asteroid strike depends on its size and speed, but even a relatively small one could unleash energy equivalent to thousands of nuclear bombs. The immediate effects would be devastating: a massive explosion, fires, and an enormous dust cloud that could block sunlight for months or even years. This global cooling effect could lead to widespread crop failures and ecosystem collapse. This impact winter could cause a dramatic drop in temperatures, affecting agriculture globally and leading to food shortages. Not only would the initial blast devastate the local environment, but the global consequences would also include disrupted climate patterns and collapsed ecosystems. The survival of humanity would be threatened not just by the immediate impacts but by the prolonged loss of the ability to grow food and the breakdown of societal structures. An asteroid impact is a stark reminder of our vulnerability in the vast universe and underscores the importance of monitoring space and developing technologies to deflect potential threats. Click subscribe to this channel to get more topics you love. Supervolcanic eruption. A supervolcano is like a giant pressure cooker lying dormant beneath the Earth's surface. Unlike regular volcanoes, supervolcanoes can produce eruptions so massive that they release thousands of times more magma and ash than typical volcanic events. When a supervolcano erupts, it spews vast quantities of volcanic ash, sulfur dioxide, and other gases into the atmosphere. This enormous outpouring can lead to what's called a volcanic winter. The ash and gases high in the atmosphere reflect sunlight away from the Earth, dramatically cooling the planet. This sudden drop in temperature can disrupt global climate patterns for years or even decades. The cooling effect could lead to widespread crop failures and ecosystem disruptions. The immediate effects include burying nearby areas under thick layers of ash, which can collapse buildings, ruin agriculture, and disrupt the transportation routes and power lines that keep modern society functioning. The long-term effects are even more severe. With sunlight blocked, crops around the world might fail, leading to widespread famine. Additionally, the release of sulfur dioxide converts to sulfuric acid in the atmosphere, causing acid rain that can harm aquatic life and vegetation. The threat of a supervolcanic eruption poses a profound challenge to humanity due to its potential to cause catastrophic environmental changes and global food shortages, testing our ability to adapt and survive in a drastically altered world. The potential for widespread ecological and societal disruption makes supervolcanoes a significant concern for global disaster preparedness. Global nuclear war. A global nuclear war represents one of the most immediate and devastating threats to human existence. Picture the world's nuclear-armed states releasing their arsenals simultaneously. The immediate result would be the destruction of the targeted cities and regions, killing millions from the blasts, fires, and subsequent radiation poisoning. However, the long-term effects could be even more catastrophic and lead to potential human extinction. The widespread use of nuclear weapons would have far-reaching consequences beyond the initial destruction, potentially altering the planet's climate and ecosystems in ways that could threaten all life. The concept of nuclear winter is central here. Following a large-scale nuclear exchange, immense fires would release massive amounts of smoke and soot into the stratosphere, blocking sunlight from reaching the Earth's surface. This reduction in sunlight would lead to a significant drop in temperatures across the globe, similar to the impact of a supervolcanic eruption. Agricultural collapse would likely follow as growing seasons shorten and conditions become too harsh for many crops. Moreover, the radiation released from nuclear explosions would contaminate vast areas, making them uninhabitable for centuries. The breakdown of governmental and social structures would likely lead to widespread chaos and a collapse of the economic and social order. In addition, the damage to the ozone layer from the intense heat and radiation would increase the Earth's exposure to harmful ultraviolet light, compounding the environmental crises. The prospect of global nuclear war underscores the perilous nature of international tensions and the importance of disarmament and diplomatic efforts to prevent such a catastrophe. The survival of humanity might depend on our ability to manage conflict and avoid escalating to nuclear options. Pandemic disease. A pandemic is an outbreak of a disease that spreads across a large region, for instance, multiple continents or worldwide. If the disease is particularly infectious and deadly, it could potentially lead to human extinction. The danger of a pandemic lies not just in the health crisis but in the cascading effects on global systems. Historically, pandemics like the Black Death or the 1918 Spanish flu have drastically reduced populations and altered societies, but with modern travel and urbanization, a new virus could spread faster and farther than ever before. The real danger arises when a pathogen emerges that combines high lethality with a long incubation period, allowing it to spread unnoticed. Health systems could be overwhelmed, leading to a breakdown in social order as panic and fear take hold. The economic impact would also be profound. Global supply chains could be disrupted, leading to shortages of goods, including food and medical supplies. If key personnel are incapacitated, critical infrastructure could fail, further reducing the ability to respond to the crisis. Moreover, the societal impact of a severe pandemic could exacerbate existing inequalities, trigger severe mental health crises, and lead to long-term geopolitical instability. The potential for mutation makes the virus even more dangerous, as it could adapt to counteract vaccines and treatments being developed. A pandemic of sufficient severity could force humanity to reconsider its approaches to health security, international cooperation, and crisis management, emphasizing prevention, rapid response, and resilience in the face of global health threats. Biotechnology risks. Biotechnology holds immense promise for advancing medicine, agriculture, and industry. However, it also presents significant risks, particularly if genetic engineering and biotechnologies are misused or mishandled. The development of genetically modified organisms, GMOs, or synthetic life forms could lead to unintended ecological consequences if these organisms are released into the wild or outcompete natural species. One of the primary concerns is the potential creation of bioweapons, organisms engineered to be more deadly or to target specific populations. If such a bioweapon were accidentally released or intentionally deployed, it could cause a pandemic of unprecedented scale and lethality. Moreover, the rapid pace of biotech development means that oversight and safety protocols might not keep up with new innovations, increasing the risk of accidental releases. Another risk involves the alteration of ecosystems through the unintended spread of genetically modified species which might disrupt natural balances, leading to ecological collapses. These collapses could reduce biodiversity and alter conditions critical for human survival, such as pollination and water purification. Furthermore, the ethical implications of biotechnology, such as gene editing in humans, pose profound societal questions. Missteps in managing these technologies could lead to public mistrust and potentially disastrous misuse. As biotechnology reshapes the boundaries of life, robust international regulations and safeguards are essential to mitigate risks, ensuring that biotechnological advancements enhance rather than endanger human survival. Artificial intelligence, AI, risk. Artificial intelligence, AI, presents a transformative potential across various sectors, but it also harbors risks that could lead to human extinction if not properly managed. The primary concern is the development of superintelligent AI, an AI that surpasses human intelligence in all domains, including creativity, problem-solving, and social skills. The risk arises when AI systems are programmed with goals that do not align perfectly with human values or are subject to unintended consequences. A superintelligent AI might find ways to achieve its goals that are harmful to humans or that we did not anticipate. For example, an AI tasked with maximizing production in a factory might do so at the expense of environmental or human safety, if not explicitly programmed to consider these factors. Moreover, the control problem is significant. How can humans ensure control over a system that is potentially smarter than any human? If superintelligent AI becomes autonomous and capable of self-improvement, it might be impossible to predict or control its actions, potentially leading to scenarios where it competes with humanity for resources or begins acting in ways that are detrimental to human survival. The development of AI also raises ethical and security issues, as powerful AI systems could be used for harmful purposes by malicious actors. Therefore, alongside the technical development of AI, it's crucial to advance robust ethical guidelines and strong oversight mechanisms to ensure AI developments benefit all of humanity and do not inadvertently lead to catastrophic outcomes. Climate change. Climate change is perhaps one of the most insidious threats to human survival, as it gradually alters the planet's fundamental systems. Driven predominantly by the burning of fossil fuels, deforestation, and other human activities, climate change leads to an increase in Earth's average temperature, which disrupts weather patterns, melts polar ice, and raises sea levels. The challenges posed by climate change are multifaceted. Rising temperatures can lead to more extreme weather events such as hurricanes, droughts, and heat waves, which can devastate communities, destroy infrastructure, and disrupt food production. As sea levels rise, coastal areas could become uninhabitable, displacing millions of people and potentially leading to severe humanitarian crises and conflict over remaining habitable land and resources. Furthermore, the acidification of oceans due to increased CO2 levels undermines marine ecosystems, which are vital for maintaining the global food chain and absorbing carbon from the atmosphere. The loss of biodiversity as species struggle to adapt to rapid climate changes could lead to the collapse of ecosystems that humans rely on for food, clean air, and water. Addressing climate change requires global cooperation and concerted efforts to reduce greenhouse gas emissions, transition to renewable energy sources, and adapt to unavoidable impacts. The complexity of climate change calls for innovative solutions and sustainable practices to safeguard not only the present but also future generations. The potential for irreversible environmental changes underscores the urgency of taking action to mitigate and adapt to climate change. Resource depletion. Resource depletion refers to the excessive and unsustainable consumption of Earth's natural resources, including freshwater, minerals, forest products, and fossil fuels. As the global population grows and industrial activities expand, the demand for these resources intensifies, leading to their rapid depletion. The consequences of resource depletion are severe and multifaceted. For instance, overusing freshwater resources can lead to water scarcity, affecting millions of people and agriculture, the latter being heavily dependent on consistent water supply. This can lead to food shortages, increased prices, and social unrest. Similarly, the depletion of fertile soil and deforestation disrupts ecosystems, reduces biodiversity, and diminishes the land's natural ability to absorb carbon dioxide, exacerbating climate change. Moreover, the depletion of non-renewable resources like oil and minerals can lead to energy crises and economic instability. As easily accessible resources are exhausted, the remaining sources are often more difficult and environmentally damaging to extract, leading to further ecological degradation. The sustainability of human societies depends significantly on how effectively we manage and conserve our natural resources. Moving toward sustainable consumption, investing in renewable energy sources, and developing technologies for efficient resource use are critical steps in mitigating the risks associated with resource depletion. Ecological collapse. Ecological collapse refers to a situation where an ecosystem suffers a sharp reduction in its ability to sustain life forms, leading to a significant loss of biodiversity. This collapse can be triggered by a combination of factors including deforestation, pollution, climate change, overfishing, and invasive species, which disrupt the delicate balance of the natural environment. The impact of ecological collapse is profound as ecosystems provide essential services that support human life. These services include purifying air and water, pollinating crops, regulating climate, and cycling nutrients. A collapse can therefore lead to dire consequences for food security, health, and the economy. For instance, the decline of bee populations affects pollination rates, which directly impacts food production, particularly fruits, nuts, and vegetables. Moreover, as ecosystems deteriorate, they become less resilient to environmental stresses such as extreme weather events, further enhancing the likelihood of their complete collapse. This loss of resilience can create feedback loops that accelerate the degradation and make recovery increasingly difficult. Preventing ecological collapse requires maintaining biodiversity and ecosystem health through conservation efforts, sustainable management practices, and restoration projects. It also necessitates tackling the root causes of environmental stress, such as reducing greenhouse gas emissions and managing waste properly. The survival of humanity is deeply intertwined with the health of our planet's ecosystems, emphasizing the need for immediate and sustained action to protect and restore natural environments. Space hazards. Space hazards, including asteroids and comets, represent existential threats to human survival, with potential impacts ranging from regional to global catastrophes. An asteroid impact, depending on its size and velocity, could unleash massive energy, causing widespread destruction through shockwaves, heat, and tsunamis if it strikes in or near large bodies of water. One of the most famous historical examples is the impact event that led to the extinction of the dinosaurs 65 million years ago, known as the Cretaceous-Paleogene extinction event. A similar event today would have devastating consequences for humanity. Immediate effects would include the annihilation of cities or regions where the impact occurs. Global effects could encompass a nuclear winter scenario where debris thrown into the atmosphere blocks sunlight, leading to drastic drops in temperature worldwide. This would significantly disrupt agriculture, potentially leading to global food shortages and societal collapse. The long-term impacts could include mass extinctions, ecosystem disruptions, and climate changes that could persist for decades or even centuries. The potential for such catastrophic outcomes underscores the importance of developing robust planetary defense strategies and early warning systems to detect and potentially deflect incoming space objects. Besides asteroid impacts, other space-related threats include solar flares and gamma-ray bursts. A powerful solar flare could disrupt Earth's magnetosphere, leading to severe damage to the electrical grid and satellite communications. Gamma-ray bursts, though extremely rare and unlikely to be directed precisely at Earth, could strip away the planet's atmosphere if one were to occur close enough. Mitigating these risks involves several strategies, such as improving Earth-based and space-based surveillance systems to detect and track potentially hazardous objects. Developing technology for deflection missions could allow humanity to redirect an incoming body if detected early enough. International cooperation is crucial in these efforts, as space hazards are a global concern that requires a coordinated response from multiple nations and space agencies. Overpopulation. Overpopulation occurs when the planet's ability to sustain its inhabitants is exceeded by the number of people living on it. This issue can exacerbate many of the existential risks already discussed, such as resource depletion, ecological collapse, and climate change. The primary concern with overpopulation is the increased demand on the Earth's resources. As the global population grows, so does the need for food, water, energy, and space. This can lead to intensified exploitation of resources, further accelerating environmental degradation. Overpopulation can also strain infrastructure and social services, leading to overcrowded cities and inadequate healthcare, education, and sanitation. Furthermore, overpopulation can intensify economic disparities and social tensions. As resources become scarcer, competition for these resources may lead to conflict both within and between nations. Moreover, the environmental impacts of overpopulation, such as pollution and habitat destruction, disproportionately affect the poorest communities, often exacerbating issues of inequality and social injustice. Mitigating the risks associated with overpopulation involves a multifaceted approach including promoting family planning education, increasing access to contraception, and improving women's education and economic status, which are all proven factors in reducing birth rates. Additionally, developing sustainable agricultural practices, improving water management, and investing in renewable energy can help accommodate a growing population more sustainably. Technological disruption. Technological disruption, while often driving progress, can also pose existential risks when new technologies destabilize economies, societies, or environments. Rapid advancements in technology may outpace our ability to understand their implications fully, manage their use, and mitigate potential harms. For example, automation and AI could lead to significant job displacement, creating economic instability and widening inequality if not managed properly. Similarly, the misuse of advanced biotechnologies could lead to unforeseen consequences in human genetics or ecosystems. The development of lethal autonomous weapons poses new risks for global security and warfare. To manage the risks associated with technological disruption, it is crucial to foster robust regulatory frameworks that can adapt to the pace of technological change. This includes establishing ethical guidelines for AI and biotechnology, investing in education and training for jobs of the future, and ensuring that technological advancements are accessible and beneficial across all levels of society.